Okay, this is Florence, the mathematics user, and we are looking at functions. But today our focus will be on the inverse of a function. Now, for inverse of a function, we equate the given function to y. The next thing to do is to interchange the x and the y. Then finally, you make y the subject. So over here, we have our function which relates to 1 on x plus 3. So from the given note, we equate our j of x to y. And we know that j of x is 1 on x plus 3. So y is equal to 1 on x plus 3. The next thing to do is to interchange x and y. So in place of y, we write x. Then in place of x, we write y. The next thing to do is to make y the subject. So here, we have a linear equation involving fractions. So this is what we can do. We cross multiply. So we are going to have x multiplying y plus 3 is equal to 1 is equal to 1. Now the next thing to do is we want to make y the subject. We want to make y the subject. So this is what we can do. Since x is multiplying this term, x will divide because x can be described as the coefficient of this term. So we have y plus 3 is equal to 1 on x. Now we want to make y the subject, so this constant will move to the other side of the equal sign, where we have y is equal to 1 on x minus 3. So the inverse of this, which is 1 on x minus 3. Let's come to this side. This is the given function where we have x plus 5 on x minus 3. So as we learned earlier, we equate the function to y. So we say let y equal to f of x. And our f of x is x plus 5. So we have y is equal to x plus 5 on x minus 3. Here, we interchange. So interchanging will give us, when we see y, we write x. So x, and when we see x, we write y. X is equal to y plus 5 on y minus 3. The next thing to do is to make y the subject. So since it's a linear equation involving fractions, we cross multiply. So here x will multiply y, x will multiply negative 3. And the reason is that we have just a term, one term on both sides of the equal sign. So our x multiplies y minus 3, which is equal to y plus 5. We can move on. Then we can even expand this. So we have xy minus 3x is equal to y plus 5. Because our focus now is to make y the subject. So now let's group all the terms containing y on one side. So we are going to have xy here minus y is equal to positive 5 plus 3x. Now, when it comes to making a variable the subject, and the variable appears twice in different terms, or it appears in different terms, we apply factorization. So here we want y, but y is in this term and also here. So we factorize our y out. We are going to have x minus 1 is equal to 5 plus 3x. Then now, since we want to make y the subject, the sign of operation between the y and this term is multiplication. So therefore, the term here is going to divide. So our y is equal to 5 plus 3x on x minus 1. So the inverse of f of x is 5 plus 3x over x minus 1. Now we want to prove something. Assuming that the inverse is given, how do you obtain the original function? So now we are going to use this as an example and check if we obtain our 1 on x plus 3. So the inverse of this function, we had 1 on x minus 3. Now we are going to use the same procedure. We'll equate the inverse to y. So y is equal to now the next thing to do is first of all interchange x and y. So our y is equal to 1 on x minus 3. Now we interchange. So y becomes x and x becomes y minus 3. Now let's look at what is happening here. Here, we multiply through by the LCM, which is y. So we are going to have y times x, which is xy. Now, y multiplying 1 over y will give us 1. Then y multiplying minus 3 will give us minus 3y. Our focus is to make y the subject. So here, let's see. We have xy here. Minus 3y becomes plus 3y is equal to 1. Are we together? Let's see. Since y appears in two different terms, we factorize. So our y into bracket x plus 3 is equal to 1. We want to make y the subject. So x plus 3 will divide. So y is equal to x. Y is equal to, 1 on x plus 3. And look at what is happening. We've obtained the original function. So therefore, our f of x is 1 on x plus 3. So this is base of inverse of a given function.